All right. Did we not get to the 8 LEDs last class? Did I not tell y'all to hook those up? I got one that says I did not. We didn't get to the 8 LEDs. Okay, so we did hook up the 2 LEDs, right? I see you, Avery. We got to the 2 LEDs, right? Okay. So here's what we're going to do tonight. Tonight, and I'm going to go ahead and let everybody take a few minutes to go ahead and start hooking this circuit up. This is 8 LEDs hooked up to the Arduino, starting at pin 9 to pin 2. Now, this would be way too troublesome for me to go A1 to A2, A3 to 8, blah, blah, blah. All right, so here you're going to start trying to figure it out for yourselves how to hook this circuit up. Now, this is identical to every single circuit that we've hooked up, except for there's just more parts to it. All right, that is absolutely it. There's just more parts to it. This positive here, let me get my pin out. This positive right here, this is the long leg of the LED, the long leg. So just make sure and the wires, the color of the wires does not matter. So just make sure you have the long leg plugged in here to the LED and the short leg going into the ground. Now everybody's showing up. Okay. All right. I'm going to give y'all a few minutes to try to hook this up. Let me know if you need help. I'll try to walk you through it. It's not necessarily replacing the other ones that we did. We're adding to it. So this is the 2 LEDs that should already be hooked up here. So now you just got to add 6 more exactly the same way you did. Now, I will tell you, it does help to give yourself some space in between the circuit. And what can be done, let me get a different pin out. You can use this side of the breadboard as well. You got to think a little bit for yourselves here, try to hook it up. But take this wire here, take another grounding wire. Remember, this wire here should already be hooked up. This grounding wire here for every class here on out, I'm going to go ahead and assume that black wire is already hooked in. All right? And then if you want to use this side of the breadboard with the resistors over here, what you can do is take a wire here and jump it over to here like that. So there's another option for y'all to hook it up. Long leg is the positive. Long leg is the positive. So positive, long. And then negative is short. And then just make sure all your resistors are hooked in the ground. Now remember, the main concept behind a circuit is where the Latin word comes from of circle. Circle. Right? So it has to start at some place, do some stuff, and then come back around to the exact same place it started at. So I know the ground is not technically you're not plugging it into the exact same place, but electrically it's the same place. These are the exact same 330 ohm resistors. If your LEDs break, you can grab another one. No, we're not going to be using all. At least I don't think we are. But you can actually get LEDs at Radio Shack for pretty cheap. They're like, I don't know, $1, $2, maybe not even $1. You can be one of the few people that actually know what Radio Shack is for. Go in there and actually buy an LED instead of a phone or whatever bull crap they try to sell you nowadays. Radio Shack really blew its market when it went into the phone industry. Raise your hands when you think you have that circuit hooked up. Let me know if you need help hooking it up too. I'll try to walk you through it. I just can't. I think it'd be redundant if I just keep saying, A1 to A2, etc., etc. I need to do that, I will, but I'd rather not. Good job, Mr. Kevin. This does get a little tricky. I know to hook it up, especially in those tight places, but oh. Can the resistors be not diagonal? Yes, they can not. You can hook it up however you want to, as long as they're going from the short leg to ground. Yeah, short. Make sure it's in the short leg of the LED though, Avery. And technically, you could put it in the other leg, but then it's not a complete circuit. Ugh. Oh, I'm tired today for some reason. But last class we did get both LEDs to light up and on and off, right? Tell me I got at least that far. Okay. Does this girlfriend that live in Canada, does she, Gabe? Just checking, just checking. I don't really teach classes in person, Gabe. There are labs that we do. I'm sure. You ask Mr. Dubik, and he'll probably definitely let you do one of the labs. It won't be me though. Maybe I need to come up there, Raleigh, for one lab. That might be fun. I don't know. Maybe I'll come up there for the robot thing and do that one night. I don't know. Maybe we'll see. I think you just want to get out of the house because you're grounded. All right. How's everybody coming? It's going to be 8 LEDs, Mr. Manuel. And make sure you have them plugged in from pins 2 through 9. Actually, I just realized I have to adjust all my pins. Let me do that real quick. There we go. Y'all have a very different definition of grounded than I had. You just leave the house whenever you wanted to. Good job, Andrew. Thank you, sir. Stop typing, Gabe, and freaking plug stuff up. I'm just talking to fill in the space, but I get bored. I'm sure Mr. David will tell you. How's it going, David? While we're waiting, Gabe, do you want the invite for the 10 o'clock class? All right. That give me something to do. Just raise your hands when you think you got it, Manuel. So I'll know that I'm not waiting on you. Huh. So I wanted to send it to you after class. Well, maybe not. Maybe I can get to it to email. Let's find out. Nah, I get paid to teach this, Gabe. Come on now, you think they can have a teacher like me and not pay me? I know how good I am. Avery, Gabe, how y'all coming? Y'all last two with hands down. Okay. Except for engineering. Engineering, they have, like, there's no getting around that. They have to pay us. Engineers have the highest paid internship out of every single college major, including medical. To some extent medical, not last year medical. That's a whole different story. Okay, well, y'all are, if I got a few more people finishing up, and then we'll start coding. Let me go back here. All right, cool. Everybody's done. All right, let's go over a few things just to reiterate some stuff here. I'll pull up this is just the original Blink code. We're going to be dressing this up a little bit, so you don't have to worry about it right now. All right. What is the purpose of the void setup? Either raise your hands or type it out. to initiate the program. That is actually an acceptable answer. I like that answer, David. So the void setup, let's just remember there's a key functionality to the void setup, and that is it only runs one time. It only runs one time. That is its key functionality. It does not continuously run, unlike the void loop. The void loop continuously runs over and over again. It gets to the bottom of the code, goes back up to the top, and keeps going over and over and over again. There are tricks to make it not do that, and we'll get into that later. But for the most part, void loop reads straight down over and over. As long as it has energy, as long as it has electrical potential energy, it will continually to run. Volts. As long as it has energy, it will run. So, from last class, if we were to actually code up all 8 lights of all 8 of these lights, it'd get really, really lengthy. All right, the code would get really lengthy. So, and programmers are what? Got one answer. David knows the answer, or Avery knows the answer. I know David knows it. What are programmers? Kevin? Yep. Cool. Lazy. Programmers are lazy. If I was to write, except for their teachers. So this is how a very, very bad programmer, i.e. me, when I first started programming, would get all 8 LEDs to light up. All right. Here I've initiated every single LED. I've initiated them all as an output. And so forth and so on. So, and here you can see I got a whole lot of code. Now this code does work. Yeah, I mean, I got it running on my Arduino right now. It works just fine. But there is a whole lot of easier ways to do this. So, let's see if y'all can get it. I'm going to try to lead y'all to it without giving you the answer. So, what have I done here? I've done everything. I've just repeated the exact same steps over and over again. Only thing I've done was change these variable names. Here I have LED2. And remember what I said about the naming of the variables. It doesn't really matter. I did this up here for 2 reasons. The one to show that it doesn't matter. Here you can see where I have what should be LED5. I've named it Illuminati just because Gabe likes throwing Illuminati jokes and figured I'd just change it up to something. So that name doesn't matter as long as I keep using that name. So here you can see I use Illuminati. Down here I use Illuminati. It's the same thing. I could put LED5 just as easily and it would have been the exact same thing. Now here I'm doing the exact same thing over and over again, or I'm doing multiple iterations of the exact same thing. How do you think is another way I could do this? I tried to drill it in. I drilled into your heads during scratch. Bind the code together. I got an array. That's actually a good answer. LED1, LED2. That actually is not bad, Mr. Avery. You're not that far off. So we could use what's called another type of loop. So the void loop is the main loop, all right? And other programming languages, that main loop has different syntax. But you can use what's called a for loop. Remember that? There we go, Kevin. Good job. We can use the for loop, which does everything repeatedly, everything inside the loop repeatedly for a certain number of iterations that you define. brain getting sick. All right. So here, and in this case, this will change a little bit for this code, by the way. You don't have to do the int LEDs pin 2. And if your Arduino is not plugged up to your computer with Arduino open, go ahead and do that. And then we'll find out how good you are as far as the circuits. I don't like the fact that he just put this big Ghostbuster symbol on here, because sometimes you do need to do this, sometimes you don't need to do this. It's all depends, but in most cases with Arduino, you do need to initialize variables the same way I've already taught you as far as the int LED pins equal whatever. All right, but for this code, we're going to kind of say that it doesn't exist because you don't necessarily have to do it because you're not manipulating any variables. Here in Scratch, we use the repeat loop, and a repeat loop, I can repeat a certain function for a certain amount of times. All right, and we're going to do the exact same thing in Arduino, just with a for loop. So this is our syntax for our for loop. Don't write this yet. This one will not do anything yet. But I just want to show you the syntax for it. So let me get my pen out. So it's called a for loop because, well, that word right there says for. All right. Yeah, I'm not going to get into the binary code and all that other fun stuff yet. So this int counter here, this is known as my initializer. This is where the count or the for loop starts, or this is where the count starts. But it doesn't have to say counter. It could say Angelina Jolie, or whatever reason you wanted, whatever name you wanted to say there, you could say. And then here, I'm saying it starts at 0. It's going to go up to 9, right? Because it's not going to go past 10, because counter 9 is less than 10, but it won't go to 10 because it doesn't say less than or equal to. And this is known as my, what is that called? I forgot the actual programming name for that. That is our, not C++. It's not our iterator, it's not our counter. Incrementer. There it is. All right. This is our incrementer. And by having this plus plus here, all right, all that plus plus is saying counter, and I'm just going to write C over here. Counter plus 1. All right, because this is used so much that they just gave it a special syntax. But you can just say C plus 1, or I can say C plus 2, and it would iterate a little bit different amount of times, and we're going to experiment with that a little bit. So again, this is the initializer. This is the confined, or what confines it, and this is how much it actually increments by. So, and this could be plus 5 if you wanted to, or whatever. There's certain different reasons why you would have a different variable, but we're not going to get into that this class. All right. And then this print line thing here, this just says, this is what it's doing, all right? We haven't really covered what this is yet, so we'll cover that next section. But this is just what it's doing. So you have an int counter equals 0. All right, and again, I could say counter, I could change this number 2. I could change this to 5 if I wanted to. If I change that number to 5, it would go 5, 6, 7, 8, 9, and then stop. All right. Maybe I will put serial print in here. I don't know. We'll find out. You just keep going here. All right. Yes, you do need to put the 4, but not like that. So this I do want y'all to type out. And make sure, pay close attention to where it's located in this void setup, and pay close attention to the braces, to the little squiggly brackets, whatever you want to call it. This I want y'all to type out. All right? And while you're typing, I'm just going to keep explaining what it's doing. So we're saying, if this is a for loop, we are essentially doing, let me pull up. Is it this one? Yep. we are essentially doing all of this right here. This is what this is doing. So this line of code is taking place of all 8 of these. So 2 lines of code take place of all 8 lines of code. You should be writing a brand new code right now. I'm sorry. I did not clarify that. That was my bad. This is a brand new code. So just go to File, New, and start typing. Raise your hands when you have this line of code or these lines of code put in there. Now, here's a little trick to computer logic. It starts counting at 0. So to a computer, 0 is actually 1. That's where it starts counting. All right. So if I said 0 less than 10, it's still going to count up to 10, but it's only, as far as number wise, it will only count to 9. Does that make sense? Because it counts 0 as a factor, I guess. Most people know when we start counting at 1. Well, computers start counting at 0. And don't load anything yet. Nothing's going to work until we get to the next line of code. Or next lines of code. And this stuff here is useful for when you're doing multiple types of sensors. And so, like, if you actually got into robotics, yeah, that looks right. You're putting that in Arduino, though, right, Gabe? Not in the question block. Oh, output should be capitalized. The output word should be completely capitalized. Yeah, that should be blue, just like mine is here. That's remember, output, pin mode, all those stuff are keywords that have certain functionalities inside Arduino. Where's my other code? There it is. It should look something like this. And let's delete that. We'll delete that. All right. So I got this is the full code here that we're going to start kind of experimenting a little bit with. Actually, yeah, we are going to change this one up here a little bit. For one, I'm going to put this. So you can go ahead and type out all this. I'm going to put here, I'm going to put flux capacitor equals 1,000. Flux cap. And flux capacitor. Now, once you get all of this typed in there, let me make sure that every single one of your LEDs should light up. Let me make sure that I did everything right. And what should happen is they should all flash on, and they should all flash off. Yes, type out every single thing you see here. Now, here's the main thing that's going to trip y'all up, is watching out for these curly braces here. So this open curly brace actually corresponds to this curly brace. So open, close. Get another pen color out. And then this one corresponds to this one. All right, don't forget these. These will trip you up quicker than running through the forest barefooted. All right, that one corresponds to that one. Yeah, you don't actually need this here. That's just a leftover from the last code. I just didn't feel like erasing because I'm lazy. Don't need that. As long as you have this here, it'll work. Now, go ahead and put hands down. Go ahead and raise your hands when you have it done. You uploaded it, and it's flashing, and your lights are flashing on and off. Everything above the green line. Yeah, you're going to need all of this, Gabe, here. Or not Gabe, Avery. You're going to need everything in this. This is the void setup. I just put that to underline saying that this is taking place of all this. And then put everything below here as well in the void loop. Okay, I misunderstood your question there, Gabe, or Avery. Now, while y'all are still typing here, so the reason I put this right here, the reason I put that, it's just because I know y'all want to try to experiment with the time a little bit, make it flash faster, longer. That way here, instead of changing the number twice, you can just change it once. And you see how the code will react slightly differently. Just saw one thing that might confuse you. Let me get rid of that. There you go. Cool. And Kevin, David, are all your lights flashing on and off? Gabe, you too? All your lights are flashing on and off, so you hooked up the circuit correctly? Nope, Gabe put his hand down. Every single light that you plugged in there should be flashing on and off. Okay. Okay, you got some error here. What did you get? Expected initializer before it, unqualified ID before 4. All right, send me your code, Gabe. Let me see that. Hang on. I'm trying. Takes me a while to copy and paste from this side. Alright. So let's see what Gabe did wrong here. don't actually need that. That looks good. That looks good. Looks like you're just missing, oh, you're missing the curly brackets right here. The first one for the void loop and the last one for the void loop. Let's see if that one checks out. Oh, nope, something else is still wrong. Out and a semicolon here. Oops. Yes, you still need, this is the void setup. You still need this. I'm trying to keep the main code up over here. You just didn't need this right here. You didn't need this int LED or even any of this. Here, let me erase some of that for you. This is the code you need. You missed this bracket here. Oops, not that one. You missed this one here and this one here. So you had everything right except for the brackets inside the void loop. So like when you're actually typing out these codes, here, let me show you what I do. So when I do these codes, I do it like this. Void, setup. And before I even do anything, I go ahead and put my brackets here. Right? And that's my first step before I even do anything. Right? So I'll put those brackets here knowing that I have to fill everything in between those. And the same thing for the void loop. Come here, enter. Whoops, I spelled loop wrong, but you know what? That's an easy fix. Void loop. So wherever I'm using brackets, I always make sure that, even for the for statement, here's how, like before I even really type out my for statements, I do for here, like that, and then put brackets like that. And then I start filling it in. I type this out first before I type out anything else. I think you're missing, let me see what's to say, obsolete binding at counter, expected semicolon, oh yeah, right here, I don't think you had that semicolon right here at this flux cap. That's telling you that you're missing a semicolon somewhere. Alright, I'm not seeing hands go up. So are y'all having errors in the code or errors in the circuit? I only got 2 hands up. Talk to me, people, so I know. Help me help you. You're really late, Zach. You missed pretty much 3/4 of the class. Alright. So, Gabe, it's looking like you're not, yours is saying that you don't have the right serial port connected. Yes, please, Avery. Send me your code, and I'll diagnose the code. Kevin went offline for some reason. Alright, let's see what Avery did wrong. Alright. I think he got You got curly bracket. You got curly bracket happy. All right. So the first thing is I see, this is just the first thing I notice here. I see a closed one here, a closed one here, an open one here, open one here. You got way too many, and delete this. Delete that semicolon, change this to an open. That's good. That's actually good. That's good. This one here, you got another close, you need to open, and that should check out. There you go, you catch all that. Oh, wait, I missed something. Oh, you put a random semicolon here at void loop. Oh, what else do I got? Oh, you don't have, you said counter less than, but you didn't put a actual number there. So we need that. And, oh, and a semicolon here. And that should check out. Yes, you can play with the blink time all you want to. All right, Manuel's up, Kevin's up, Gabe's up, David's up. Zach, do you want to jump in on the 10 o'clock class to kind of catch up, man? Because there'd be no way I can catch you up right now. There you go, Avery. Andrew, how you coming up there, man? You've been quiet tonight. So, Manuel, are your lights flashing on and off? Like, all 8 of your lights should be flashing on and off. Cool. Seizure, please. Oh. All right, Zach, now, you're not going to miss that much. You're going to miss the whole thing about for loops, Zach. I'll have to, when we get to for loops, or when we do for loops again, you have to remind me. If you only have 2 lights going, but your code's I literally just uploaded your code to mine, and it works. Means your circuit's not right. So which is it? The 2 lights that we had hooked up before, or those are the ones that are still working? So do you want the invitation? Okay, I'll send you and Gabe the invitation at the class, Zach. Remember, it's at 10 p.m. All right, so for those of you that have it working, let's see, instead of all the lights flickering on and off at the same time, let's see if you can make it so it flickers one off and one on at a time, so be incremented. Actually, with 10 minutes left here, let me just cover this stuff. I can't remember if it was delay time or... let me get a opinion. Would y'all rather see the code like this, or would y'all ever like to see me actually type this stuff out like I did here? Which one do y'all prefer it like this, or would y'all like it like this? Y'all want to see like me actually type it out and stuff, right? Or no? Either way, I don't care. What's your question, Gabe? All right, David. Let me find the code. All right. So this code. Is this the one I typed? Yep. So this is my code. You can copy and paste that. That should work. Yeah, but if I just keep copy and pasting, Gabe, you never learn anything. All right, so we've actually simplified this code down from all those lines of code now to just a few simple lines of code. Now, the way it's done, the way we did this is I kind of like it, but I kind of don't. One, because let's look at exactly what we're doing. We're using two identical for loops, right? We're using two identical for loops. Pretty much both of these here are identical, right? The counting iteration, when I say identical, this is the part that's identical. So there's no reason, and don't do this, I'm just kind of explaining here, because I want to change something up. But I could take this and put that in there, and I put all the delay times, and the code will work exactly the same way. Just keep, no, don't, you should have this code already. I've already sent you this code, Gabe. All right, which is a whole lot simpler than trying to do something like this. Now, this one, they used a little bit different syntax. What they used was arrays. We're not going to have a chance to get to that tonight. So I'm going to kind of skip down. I don't like the way they did that. So to make it so that the lights increment one on and one off, the only thing you have to change, or the only thing you can have to put in there, is this right here. Put this in there for each for loop. All right. So I'll do it both ways. I'll keep it. I'll keep this up, and then I'll pull up my code. There it is. Here. And if you just add a delay here, you're going to change the functionality of it. So let's do that. And I'm actually going to delay. What I use, flux capacitor. I'll put, I'll put who here. And here, I'm going to come up here, say int who equals 250. Who, as in, so flux capacitors from Back to the Future. Who I'm using as Doctor Who, because both they're only dealing with time. I don't know if I got that reference or not. Delay 250. Oh, wait, nope, delay who. Who. Upload that. And this should change up your code a little bit to where your lights are kind of going on. They're going on incrementally, and they're shutting off incrementally. Instead of just all on and all off, it should be just, up and down, up and down. Now, with that done, what you could do here, now, and feel free to experiment with this outside of class to try to change this up. So here I'm incrementing, but I can actually switch this around to a decrementer. All right, increment and decrement. If I change these numbers around, for example, let me show you, because my circuit's not hooked up like that. So if your circuit is hooked up like that, right? And what I call, so pretty much they're all kind of lighting on, like this one shuts on, this one shuts, then off, then on, then off, then on, right? But you can make it look like it's the Knight Rider effect. So it's coming like forwards and backwards, forwards and backwards. To do that, it's a really simple change in the code. And this isn't on the slide, so I'm going to do this one here. So here, I'm going to change this here to 10. So I'm changing the second for loop up. Instead of going up, I'm going to make it go down. So I'm starting at 10. I'm going to go to 2. And instead of int counter plus plus, I'm going to say counter minus minus. And I'm going to change the who to, I'm going to change that to 100. And this to 250. Then that should give me the effect I'm looking for. Let's see. That's just staying on. What did I do? Counter flux. Yeah, I see that. They're all just on. What did I do? Counter less than 2, counter minus minus. Let's try this. 2, I don't think. Give me 1 second, I'll figure it out. That had a weird effect. Counter 10. Counter less than 1. Counter low. You don't have to write this. I'm just putting this in here so I can try to figure out what's going on. It's not even getting to that. So I think what I gotta do is do this. Counter. Why are you getting like that? 1 second. Oh. Now I can open a bar and have these cool lights. Yep. It's not even getting to the second one. Flux cap, delay counter. All right, I got one more minute here. All right, I'm going to switch it back up here. So we were using two different for loops, right? But you can switch it all into actually one for loop. All right, and that's kind of like the main purpose of this exercise, to realize that I can take all of this here, I can delete this, and remember how I said that both for loops were exactly the same as far as counting wise. Let me erase my pen marks. All right, so who, that works. If I delete this, don't worry about that one. I'll explain that one next class. Here, delay who, and then digital, right. Did I spell it right? Something, I didn't do something right. Digital right, counter low, like that. Oh, I forgot something. This code. If you upload this code, you'll get it kind of a cool little effect. It's not the effect I was looking for, but add that in there and it changes it up a little bit. So I was using two for loops and a whole bunch of lines of code, and I just simplified it down to one for loop. All right, does that make sense to everybody? Did I kind of, I don't know, I don't think I explained all that stuff too well. What do y'all think? And here, I'll post the code. This is the new code here. Copy, paste. So, Kevin, what's a for loop used for? What about you, Emmanuel? What's a for loop used for? What word do I keep using to say what a for loop does? Anybody? Repeat, iteration, stuff like that. It will continually do something, repeats a certain set. Yes, that's true. Not necessarily over and over again, Avery, but it does it for a certain amount of time that you specify using whatever you have here. All right, so that's the key feature, is that it does everything inside this loop for a certain amount of times, depending on what this here says. All right, and that gets to be this functionality gets to be pretty important. I'm going to try to incorporate more of the for loop stuff when we get into the robotics, because I think it'll make a little bit more sense if you see something moving around for a certain amount of times. So we'll do that next, or we'll do that hopefully when me and Tom can figure out exactly which robot to get y'all. All right. So next class. Should I do arrays? I'm debating on arrays. I want you to keep this exact same circuit hooked up for next classes. Raise your hands if everybody got your lights to flash. Every single one of them, all 8 of them. Okay, cool. Zach, I'll get you at 10 o'clock. All right. But, Zach, are you on Edmodo, sir? Mr. Zach. Take care, Avery. All right. Zach, on Edmodo, it was this circuit should be posted somewhere. I need you to have this circuit hooked up by 10 o'clock. Think you can handle that? Yay, nay, maybe. You're not even there. All right. I'm going to go ahead and bid y'all adieu for right now unless y'all have any further questions. Zach's not responding, so I'm going to assume he's not there. So going once, going twice. I will talk to y'all next class.